Well, hello, Period 6. I'm sorry I can't be with you today, and I hope you had a chance to whiteboard your answers to Worksheet 2, and I hope you're confident in those answers. And just in case you're not so confident or you just want to get my approval on things, I'm going to go through the worksheet with you so make sure that everybody is leaving the room on the right page, on the right foot, and then we'll start worksheet 3 together. Your homework will be to do page 9 in the packet, the second page of worksheet 3. And then we'll talk about it next class. Okay, so let's get started. So the first problem of worksheet 2, you have a position time graph, and the position, instead of writing the whole word position, you could just write X, because we're going back and forth on the number line, which we're calling X. And we have two objects, two cyclists, cyclist A and cyclist B. Do the cyclists start at the same point? How do you know? If not, which is ahead? Well, if they were to both start at the same point, they would be at the same point on the x-axis at time equals 0. But A starts here at x equals 0, so on the number line, A would be starting right here, and B starts ahead of X, somewhere in the positive. Let's make that an A. Okay, so do the cyclists start at the same point? No. How do we know? Both lines don't start at the same point. They don't have the same y-intercept. Let's see. So object B is ahead. Ooh, gotta work on this handwriting. Okay, so at t equals 7 seconds, which cyclist is ahead? So we could look at this and we say, okay, 7 seconds is after 5, so it's somewhere over here. We look up here, and now A is higher than B, so A is ahead of B. So at 7 seconds, A is ahead of B. Which cyclist is traveling faster at 3 seconds? Well, to look for how fast they're going, we need to look at the slope. Object A always has a steeper slope than object B. So object A is always going faster than object B. Are their velocities equal at any time? Some people want to say that they're equal right here, where the lines cross. But the slopes aren't equal, they're just meeting at the same place. So are their velocities equal at any time? The answer to this one is no. They're not equal at any time. A always has a steeper slope. B slope is always not quite as steep. So A is always going faster. Let's scroll down. What is happening at the intersections of A and B? We talked about this just briefly. At this intersection of A and B, they're meeting up. So A is passing B, just like what happened with the blue and red cars that you guys did in your lab. Okay, so now the next page, they change things up a little bit. And they say, okay, this is our old graph and this is our new graph. It looks like A still has the same steepness as before, but now it's going the opposite direction. So how does the motion cyclist A in the new graph compare to that of A in the previous graph? I would say the same speed, because the steepness is the same, not the same velocity, because velocity is a direction and a speed. And cyclist A in the new graph is going in the opposite direction. This is going to take some practice to write with this thing. Just opposite direction. Okay. How does the motion cyclist B in the new graph compare to that of B in the previous graph? It looks exactly the same, so it's the same. No different. Which cyclist has a greater speed? So now again we look at the steepness, and even though A is going backwards, the line of A is still steeper than the line of B. So A has a greater speed because it has a steeper line. What is happening at the intersections of A and B? Well, you can't really say A is passing B because the cars are going in the same direction. But you could say that they cross each other. One is like passing each other in opposite directions. So B is going this way, A is going this way, and they pass each other. So you could say it's passing B in opposite directions. Okay. And which cyclist traveled greater distance during the first 5 seconds? Oh, this is a great question. So let's look at this. So in the first 5 seconds, B went from here to here. This is B's change in X right there. And A went from here to here. So A's change in X is that one. So A went much further, traveled that much further. B just traveled this little bit. So A traveled much further than B in the first 5 seconds. Okay. Let's go to the next page. This page is excellent. Okay, so first we're going to look at displacement. So first, let's look at displacement. It says rank these situations from greatest to least, which shows the greatest displacement during the time from 0 to 10 seconds. So the graph right here stays at 25 meters. So the object isn't moving. So the displacement is 0 meters. Same with this graph. Object isn't moving, it stays at 5 meters, so the displacement is 0 meters. This graph, we start at 0 and we end at 10, so our displacement is 10 meters. This graph, we start at 3 and we end at 10, so our displacement is 7 meters. This graph, we start at 15 and we end at 0. Be careful, this is 10 seconds. We end at 0 meters. So our displacement is negative 15, because remember displacement has direction. So we need to have the negative in here, say that we were going backwards. And then this one, remember displacement just goes from where you start to where you finish. And where I finished here is at 5. So our displacement here is 5 meters. So now all we have to do is put this in order. The largest number here is 10, so that was for C. And then the 7, which is D. And then the 5, which is F. And then the A and B. And then the negative 15, which is E. Okay. So now, let's look at distance. Now the distance this one traveled, again, is 0. It's just staying in the same place. Some of you on your quiz probably wrote constant, but you have to write, or constant speed, and that's not quite enough, because you could go with constant speed. This graph C is going at a constant speed, but it's not 0. So if the graph stops at 0, you must say in describing the graph 0, or 0 speed, or stopped. So the distance traveled here is 0 meters, and the distance traveled here again is 0 meters. And the distance went from 0 to 10, so it's just again 10 meters. And over here again 7 meters. Now, for distance, we don't need a direction. So even though we went backwards 15 meters from 15 to 0, all that matters is how far we went. So we went 15 meters. Now in this one, we went 10 meters here, we went from 0 to 10, and then we went 5 more meters here. So we went a total of 15 meters. To find our distance traveled then, we have to put these in order. So E is now equal to F, which is greater than C, which is greater than D, which is greater than A equals B. I hope you guys all got this. It's so exciting to see you guys do so well. So I really, really hope you got it. Okay. So now let's get some practice. We're going to look at having to do a graph, both in all three forms: a position time graph, so xt, a velocity time graph, vt, a written description, and a motion map. All 4 of these will tell the same story in different languages you can think of. And we're going to have to be able to interpret all 4 and go back and forth between all 4. So this worksheet, practice 3, is giving us practice with that. So if we stay at the same position for a long time, what's our velocity? I hope you said 0. Okay, so if our velocity is 0 for a lot of times, then our velocity stays at 0. An object is stopped, is not moving, and is staying at a negative position. So we have to go to any negative position here. We don't have numbers, so we just choose any negative position. And we don't have any arrows because the object isn't moving anywhere. We just have dots. Okay. Cool. Let's try the next one. Okay, so for this one, we're given a velocity time graph, and we have to get the position time graph. Well, the velocity time graph is negative, and it doesn't change. So what does that tell you about the slope of a position time graph? Tell your neighbor what you think. I hope you said the slope was negative. Now, what does it tell you about where the object starts? Tell your neighbor what you think. Well, that was a trick question. The object starts, we don't know. So as long as we draw a straight line that has a negative slope, anywhere here, any of these lines would be okay. So we have a negative velocity. They're all essentially the same slope, negative slope. We just don't know which one it starts at, so any of these would be okay. So a written description would be an object moving in the negative direction at a constant speed. Okay. Now, how would you draw the motion map? To do this, you want to pick just one of the lines to make it consistent. So let's pick this line that I'm going to draw. So we start at a positive position. location. So with motion maps, you need two elements. You need your dots to tell you where you are in between your changes in time. And you need your arrows to tell you direction. If you just have dots, or just dots with lines, it doesn't tell me what direction you're moving, so you need both. Okay, so for your homework, I want you to try the next page, just one page, and then we'll discuss it next time in class. I hope you guys have a wonderful day. I am here at lunch every day, and now I'm here after school every day. So if you guys need help, please come in. I'm more than happy to help you. All right, take care. God bless.